In the glowing arms of the Triangulum Galaxy lie the most intense and crowded star-forming regions in the cosmos, colossal stellar megacities where blue and white supergiants blaze side by side in radiant fury. These stars are monsters, reaching surface temperatures above 50 degrees Celsius, emitting energy at levels the human mind can barely comprehend. A single cluster can outshine 100 million suns, releasing so much radiation that it literally sculpts space, blasting away surrounding gas and carving vast voids in the interstellar medium. These cavities are not silent. They are battlefields. Within them, pressure builds. Shock waves collide. Gas is compressed. And like dominoes, these forces trigger the formation of even more stars. A chain reaction of stellar birth set off by the violence of earlier generations. But this beauty is fleeting. Massive stars live fast and die violently. Within just a few million years, the blink of a cosmic eye, these giants burn out, often in brilliant supernova explosions that further reshape their environment. Their deaths are not the end, but the beginning of a new transformation. These clusters evolve, not just in brightness, but in structure. Over time, something remarkable happens inside them, a process called mass segregation. As stars interact gravitationally, the most massive ones gradually migrate toward the cluster's center. Like heavyweight champions taking the central ring, they push smaller stars outward. The result is a gravitational hierarchy, a luminous core of giants surrounded by a halo of smaller, cooler stars. It's not just a visual spectacle, it's physics at work on an unimaginable scale. In the densest clusters, stars are so close together that interactions happen constantly. Some systems form binary stars, two suns locked in a gravitational embrace. Others may merge, giving birth to hypergiant stars or even the seeds of future black holes. These environments are also rich in high-energy phenomena. X-ray binaries, neutron stars, and exotic objects like millisecond pulsars thrive here. In some cases, astronomers suspect the presence of intermediate-mass black holes, invisible giants lurking at the centers of particularly massive clusters. These stellar cities are not permanent fixtures in the galaxy. They are transient, constantly evolving, dissolving, and reforming. The gravitational pull from the Triangulum Galaxy itself gradually pulls them apart. Over hundreds of millions of years, the clusters lose mass, shed stars, and disperse into the broader galactic disk. But their legacy remains. The stars they formed, the metals they forged, the shockwaves they triggered. Every supernova enriched the interstellar medium with elements like carbon, oxygen, and iron, the very ingredients of planets, oceans, and life itself. Without them, galaxies would be barren. In many ways, these clusters are the furnaces of creation. One of the most famous in Triangulum is NGC 604, a vast stellar nursery spanning nearly 1,500 light-years. It contains over 200 massive stars, each more than 20 times the mass of our Sun. This one region alone is a galactic beacon, visible across the local group of galaxies. When astronomers peer into NGC 604 with instruments like the Hubble Space Telescope or the James Webb Space Telescope, they don't just see stars. They see time, motion, and transformation frozen in the act. They see raw power and delicate balance, chaos and creation, and they see a reflection of the cosmic cycle that builds galaxies, shapes planets, and eventually makes life possible. What's even more intriguing is how similar these processes are to those in other galaxies. By studying star clusters in Triangulum, we gain a universal blueprint for how stars are born in spiral arms everywhere. Whether in Andromeda, the Milky Way, or distant galaxies a billion light-years away, stellar megacities follow similar rules. Dense gas clouds collapse, stars form in clusters, Mass segregation reshapes structure. Supernovae clear the way, and new stars rise from the ashes. It is a self-sustaining rhythm, a cosmic heartbeat that echoes throughout the universe. So the next time you see a glowing patch in the arm of a galaxy, whether in an image from NASA or a sci-fi movie, know that it's more than a pretty light. It's a city of giants, a cathedral of fire, a place where stars are born, live like gods, and die in glory. And out of that glory comes everything else.